All right, everybody, welcome back to your homework. Wrong paper. Let me flip that over real quick. Easy fix. Sorry about that. Welcome back to your star review homework for the second week. And let's go ahead and look at problem number 1 so we're ready for Monday's night's homework. So let's look. Which two expressions are equivalent? So hopefully, guys, these videos are helping you out, getting us ready for our STAR test coming up May 8th. So first of all, equivalent, we need to know that vocabulary. That means equal to. So we have two expressions. Remember, expressions have no equal sign, but we need to find the value of each of these expressions to figure out what's equivalent. So a couple of you guys look at parentheses, and we know those are grouping symbols, and that means we're going to do those grouping symbols first, and we do PEMDAS for order of operations. So that might help us out on this problem. So remember, parentheses are grouping symbols first, then any exponents, multiply and divide from left to right, and then add and subtract from left to right. So we need to have that to kind of help us. Now the next thing some of you guys might remember is that when we see parentheses, and we might not know what the value of this variable y is, so there's going to be some things that we need to go back and review. Thinking about this, we might think about those math properties we talked about. Commutative property, associative, distributive, identity, inverse, and zero product property. So that might be good to kind of remember. Now the next thing I would give you a heads up on. Our brains do not naturally think in letters. We're better with numbers in math. So some of you look at this, and like I do, I get a little overwhelmed. So here's a trick that I do that I want to show you guys. What I do is, I know how to work with the numbers. Let's give a value to that variable y. So let's just pretend that y is equal to 2. And you can plug in any number that you want. I'm just going to use 2. You can try this with 3, 4, 5, whatever number works best for you. Now that I know what the value is, or I can pretend what the value is for 2, that's going to help me decide what this is worth as a value in a number, and see if that expression is equal to the same value as this expression. So let me show you how this works. It takes practice. So let's look at letter A. The first expression is 4 plus the group 3 times whatever y is. That dot means multiply. And if we're pretending y is 2, we're going to substitute that in. So parentheses go first, so I'm just focused on 3 times 2, which I know is 6. But before that, I have the 4 plus. Now again, I cover that up so my brain only focuses on order of operations. Now in case you forgot, the reason I can drop those parentheses is there was no number right next to it. If there was a number right next to it, I need to keep those parentheses because that means to multiply. But since there's no number next to it, I can drop them. So I've done the parentheses. There's no exponents. There's no multiplying and dividing anymore because that multiplication was inside the parentheses. My last step is add and subtract. So 4 plus 6 is 10. So that kind of helps me to say, okay, if y were 2, then this value of the expression is 10. But let's see if it's equivalent or equal to the other part. If I were to group 4 plus 3 in parentheses and then multiply it by y, which again, we're going to keep the same as 2. So parentheses come first. 4 plus 3 is 7. Again, I can drop those parentheses. There's no number right next to it. And I bring over the times 2. Following my order of operations, the only thing left to do is 7 times 2, which is 14. So are these two expressions equivalent if one is 10 and one is 14? Nope. Get rid of it. We want the ones that are equivalent. So let's go to the next one. Process elimination sometimes works best for us. So look at this one. 18 divided by y plus 10. Then they changed it up. We're down to 10 pluses first and y divided by 18. So stop and think about that for just a minute before we solve it. If I have 18 and I divide by a number, say like 2, would that give me the same answer if I put that number 2 first and then divided by 18? Let's look. So let's see. 18 divided by, let's say y is 2 again. Then it says plus 10. So order of operations, parentheses are first, and I do have some parentheses or grouping symbols. 18 divided by 2 is 9. Bring over the plus 10, and 9 plus 10 is 19. So if y were equal to 2, then this value of the expression would be 19. Well, let's see what the value of the expression is over here. I have 10 plus 2 is my y, divided by 18. Again, I'm just substituting that information in. Well, 10 plus I can't do anything with, so I just bring that over first. Now I'm focused on 2 divided by 18. And remember, whatever you say first in division goes in the inside. That's called a dividend. 2 divided by 18, which is the outside number or the divisor. So how many groups of 18 would go into 2? Well, none, because that's too big. So we think about the cowboy and horse. We kick off our boots, hang up our hat, have that tortilla. There's nothing in the ones place, so we need to put a 0. Now think of this as 18 going into 20. 18 goes into 20 one time. 1 times 18 is 18. I subtract 18, 19, 20. My remainder would be 2. But I don't deal with remainders anymore. I would add another 0. There's nothing in that hundreds place. Add that tortilla, bring it down. Well, what you're going to see happen is 18 goes into 20 again one time. So this is going to be one of those repeating decimals. As soon as I see the 1 repeated, I actually can just write it as 1/10 repeating. So 10 plus the value of 1/10 repeating. But think about your place value again. If you have 10, that's 10 in 0 hundredths. When I add decimals, I line up the place value. So this looks kind of funny, but if I have 0 in the tens place and a 1 repeating in the tens place, I add that together and I want 1/10 repeating. 0 plus, well, there's nothing in that ones place. There's nothing in that tens place, so 0 plus 0, 0. 1 plus 0 is 0. So this value would be 10 and 1/10 repeating. So again, it does make a difference with division, which one we say first and what we divide by. So 19 clearly is not the same as 10 and 1/10. So we're halfway there. We got rid of 2 answers. So let's look at letter C. 12 minus the group y times 2. But remember, we said y is equal to 2. So let me rewrite that. 12 minus, we're substituting 2 in for y. 2 times 2. So let's see what that value of that expression is. So 12 minus, we'll bring that over. The group 2 times 2, well 2 times 2 is 4. And 12 minus 4, 11, 10, 9, 8. So that value of the expression is 8. Let's look at the next one. 12 minus the group. 2 is now my number, my constant, times y, which is my variable, and we're saying y is 2. Now some of you, before you even done the math, look at that. It's written exactly the same, so it should give us the same answer. 12 minus 2 times 2 is 4. Again, same expression right there. Now it's an equation because we're setting it up each time. 12 minus 4, still going to give you 8. So it is going to be C because both values are C. Right here, guys, that's commutative property. When we switch them around to multiply, we're going to get the same product. Y times 2 is the same thing as 2 times y. And if whatever that value is, we take that away from 12, it's going to give us the same value. Okay, think about what we did here. Use this trick if it helps you. Pretend there's a value for x on this side. Go ahead and solve it, and we'll see you tomorrow.